Hi everyone. So today we'll start with arithmetic progressions. So let's first understand what are the meaning of these terms. So arithmetic means related to mathematics and progression means a sequence which has a predictive pattern. So you have now a rough idea that it is something related to mathematics. Also, it's a sequence which have a predictive pattern. So you just ignore this. Now you should think that why are we studying this? Where do we apply this in our real life? So if you see, nowadays we are using a few applications like Uber and Ola to commute. So basically, I'll show you how their pricing is using AP. Okay. So if you see, whenever you try to use a Uber application, they have fixed their, for example, their base fare for the first kilometer, they have fixed the base fare to 50. And for the subsequent kilometers, for each kilometer, they will increase the pricing by 20 rupees. So for the second kilometer, they are going to increase it by 20 rupees, which is 70 rupees. Now, for the third kilometer, they are again increasing it by 20 rupees, which is 90 rupees. For the fourth kilometer, they are increasing it by again 20 rupees, which is 110 rupees. In same pattern, for the fifth kilometer, they will increase it by 20 rupees, which is 130 rupees. So if I am traveling using Uber, then and I'm traveling 5 kilometers, now I know that okay, 130 rupees will be my total pricing for 5 kilometers. So this is, if you write it in a form of sequence, it will be like 50, 70, 90, 110, 130. Okay. Now let's take one more example. Let's say, let's just take example of the natural numbers. They start from 1. I'll write it here, 1, and they increase by 1, 2, 3, 4, and so on. Okay. So now that you understand the purpose of learning them, let's also understand one more thing, which is term. So what is a term? So each number in the sequence is called a term. Okay. So 2 is a term, 6 is a term, 4 is a term. Okay. Now that you know what is a term, we can go through the definition of AP. So AP is basically list of numbers in which each term is obtained by adding a fixed term to the preceding term. Okay, I don't know if you understood or not, but I'll explain it more. So, basically, a sequence or a list of numbers in which each term is obtained by adding a fixed number to the preceding term. That means, if we add x to 2, we get 4. Okay, if we add the same x to 4, we'll get 6. Okay, so now, in the same way, if we add x to 6, we'll get 8. Okay, same way, if we add y, let's say I'm just assuming x or y. Okay, okay. So I have now these 4 series. Let's try to find out which of them are actually AP and which of them are not AP. So the first one is 2, 4, 6, 8, 10. So as I told you, for a series for a sequence to be in AP, it should increase by a fixed number. So let's try to calculate the difference between all the consecutive terms. So here let me erase it. Okay. So here if we subtract, so if we subtract 2 from 4, we will get 2. Again subtract 4 from 6, we will get 2. Subtract 6 from 8, we will get 2. So what we have to do is, when we have to find out what is that constant number, just subtract the later term, the first term from the later term. Okay. So here 4, this will be obtained 4 minus 2. Here 6 minus 4. 8 minus 6. So if you see, everywhere we get 2. The difference is 2. And the difference is constant. Here also 10 minus 8 is 2. So this is an AB. Now the next one. Let's subtract 1 from 2. So it will be 1. 2 from 3. It will be 1. 3 from 4. It will be 1. 4 from 5. It will be 1. So if you see, the difference, the fixed number by which it is increasing is 1. Now next one. So here if you see, okay, I'll come to this post this. Here let's first simplify them. 1 square will be 1, 2 square will be 4, 3 square will be 9, 4 square will be 16. Now to find out the difference, what is that constant number, we will be subtracting 1 from 4, so which is 3, 4 from 9, which is 5, subtract 9 from 16, which is 7. So if you see that the number is not fixed, it's not constant, so this is not an AP. Okay, now we have one more left here, this one. For this one I am doing it here. So we should subtract 1.0 from minus 1.0 from minus 2.0, minus 1.0. So if we calculate this, this will come to 1.0. Now next one, so we found out this one. Again the next one is minus 3.0 minus 2.0. Now it will be 3.0 plus 2.0, which is minus 1.0. So if you see, the difference is constant and it is minus 1.0. So I hope now you understood that how can we find out which all are APs and which all are not APs. Now related to this, there are few terms which we need to understand. Okay, so the first is, or let me erase this part. Yeah, so the first thing is term. Term is, so each number in the sequence, this is called a term. So here if you see 10 is a term, 8 is a term. Next is common difference. Common difference. The common difference is basically that fixed number which defines an AP. Okay, till now we All this we have calculated are the common difference. So we could find out this common difference. So like 2, 1 minus 1.0. Okay. Now next is next is finite and infinite APs. Finite and infinite APs. So I'll tell you, I have already covered this. So a AP in which there are finite number of terms is called a finite AP, and an AP in which there are infinite number of terms, it is called an infinite AP. I'll give you an example. So just now we saw like how can we calculate distance for 5 kilometers. Okay, how Uber calculates distance for 5 kilometers. So if you know that, okay, this is the last term, it is this series, this sequence is ending here. So this is a finite AP. Okay, I gave you one more example of natural numbers. Do you even know, like, will they end ever? So they can keep on going infinite. So this kind of APs are called infinite APs. Okay, once again. So finite APs are the one in which there are finite number of terms, and infinite APs are the ones in which there are infinite number of terms. And now that you have an example for both. Okay. Next is, so next thing need to be discussed is the general form of AP. So here, just now I showed you a few examples. I'll write one of them here. 1, 2, 3, 4, 5, 6. This is an example of AP. Okay. Now let's say we are calling the first term as A1, second term as A2, third term as A3, and so on. Okay. So when this is the case, the difference after subtracting A2, after subtracting A1 from A2, this is called D. So let's say this is the first term, this is the second term, this is the third term. So if you want to calculate it for second term, which is A2, okay, I'm just mentioning 2 as n here. Okay, this is the nth term. So I will say this is A2. So instead of 2, I'll use n here. An minus, here if you see A2 minus A1, one term before, one preceding term. So here it will be A n minus 1, which will be equal to D. So what is the D here? D is that common difference. Okay. So this is called the common difference. We are denoting it by D, and This is the first term. Usually the first term is mentioned as A. We don't need to write A1 or something. This is the first term. This is the common difference. And this is the general term of an AP. Okay. Now, if it is a finite series, in that case, we know that okay, this is the last term. For example, for this series, let's say we are ending it at okay, we are ending it at 10. Okay. So this one is A1. This is A2, A3, A4, A5, A6, A7, A8, A9, A10. So this will be A10. So we just want to, if for convenience, we have we it is also called as L. L means the last term. Okay. So now you are clear. A is the first term, An is the general term, D is the common difference, L is the last term.